Hello everyone, this video is going to be all about Amazon Virtual Private Clouds or VPCs. And this is going to be an overview video where I speak about some of the core ideas, the key concepts about VPCs, and give you just enough detail to help you get started with VPCs, but we're not going to gloss over every single feature, every single component that's at your disposal. That'd be by far way too much for a single video. So instead, I just want to give you the most important things in order for you to understand how VPCs work and how to navigate and use them in your day-to-day work. Okay, so that's the agenda for this video. And then the second half, we'll kind of have a hands-on demonstration where I walk you through some of the concepts in the AWS console. We'll create a VPC, we'll create a NAC gateway, we'll do a bunch of things that you'll see a little bit later on. So let's just get right into it. And before we get into what VPCs do and why they're important, I wanted to relate them to what we all have at home, right? Which is just a home network that we use to talk through the public internet. And so in our home networks, we have our home machine, we have a router. Some folks have a router that's mixed with a modem, so it gives you a little bit of a two-in-one. Then we have machines that we use, could be a desktop computer, a laptop computer here, that we connect to our router in order to talk to the public internet. You've probably seen numbers like these ones before, so 192.168.0.1 or .101 or 102 or 109, a whole bunch of numbers there. These aren't by accident, it turns out. These are a convention that we'll learn about a little bit later on. And then within any home network, we have like intra-machine connectivity, right? We can talk to our router, we can configure it, we can go to the home page, change some of the settings for our Wi-Fi, things like that. We can also talk to the other instances of computers that are in our network. So if we're on our laptop, we can potentially interact with our desktop machine if it's running. We can also talk to the outside world, right? We can talk to the public internet and we can load web pages, do what we need to do there. But the idea here is that what we have in our home network is private. The outside world, like an outside person that wants to potentially get into our network like this, wouldn't be able to, right? Because our router has a firewall built in that prevents all this incoming traffic, and it's configured to essentially only allow the right level of traffic both on the outbound and on the inbound side of things. So just random people that may have our public IP address are not necessarily going to be able to get into our network to access, the databases or the hard disks on our home machines that are running, which is a great thing. This is how it should work, right? And so the key idea here is that home networks are completely private. They're shielded from the outside world. We have private IP addresses that are only kind of relevant when you're on the local network, but aren't useful outside of that network, okay? And similarly, your neighbor has a home network, your person across the street has a home network, maybe a business in your neighborhood has one too. And these are all networks that have their own routers and their own modems and their own public IP addresses, and within their networks, their own machines. And it wouldn't make sense for us to be able to speak to their networks directly and access them, right? And so the concept of, or the statement that home networks are private holds true to not just our own network, but other networks as well. Okay, so this is kind of the general framework for how home networks work. Now, what does this have to do with AWS and why is it important? So let's get to that now. And so how does this work within the context of a VPC? So within AWS, we have a region, and within regions, we can potentially, there's availability zones. We'll get to that a little bit later on, but we create like AWS accounts, right? And AWS accounts are just kind of collections for us to deploy our resources into. And so we also have the ability to create a virtual private cloud within our AWS account, right? We can actually create multiple VPCs within our AWS account. And if you haven't used a VPC directly, or maybe you're like, oh, I've never created one before, you've probably interacted with it because AWS by default creates a VPC for you as part of your initial account for each region. And then that allows you to kind of get started with a bunch of the connectivity things without worrying about too much of the details. It sets up some liberal permissions for you and helps you basically do a bunch of things like talk to the public internet, for example. And so with a VPC, it's kind of like a isolated network boundary, right, within your AWS account. And so you deploy your infrastructure like EC2 instances into your VPC, and then associated with your VPC, you can specify a whole bunch of rules. Does my VPC have public internet access? Is it only allowed inbound internet access? Do I have resources within it that are meant to be private? Much like we had in our home network, right? We could potentially expose some machines if we want to the outside world, but a lot of the things we may just want to keep private. Maybe it's sensitive data, maybe it's databases, stuff that we don't want to expose. This is all stuff that we would locate within our VPC and set up up permissions so that we can lock it down so that not anyone can gain access, right? And so with VPCs, you can also have other users in other AWS accounts that have their own VPCs, right? And they deploy their own infrastructure into them, so they have their own isolated part of the AWS cloud, aka a VPC. You have your own. But by default, these two things are not able to talk to each other, right, from the networking level. And this makes complete sense. Like out of the box, we don't want resources that are in my VPC to be able to talk to yours unless we both have an arrangement and we want to talk to each other. We both need to kind of consent into doing that and also make some configuration changes in our VPC in order to allow that, right? So out of the box, this isn't allowed, but of course you can connect VPCs together through a bunch of mechanisms that we'll get to later. But the big idea with VPCs, just overall the TLDR, is that they're an isolated network space that's dedicated to just a collection of resources that you specify in your AWS account, okay? And you can also have multiple VPCs in a single AWS account, and the same rules would apply, right? Like if you have infrastructure deployed in one VPC and then you create another one and have infrastructure deployed there, those two things won't be able to talk to each other. It's only after you set it up correctly, either through VPC peering or another topic that we'll get into later, that they'll be able to speak to one another. So it works for both within the account if you have multiple VPCs and also cross account as well. Okay, so this is the key idea of what a VPC accomplishes. Okay, and so now let's talk about how VPCs work a little bit under the hood, right? So going over some kind of general AWS concepts here. So we have the AWS cloud, we have regions like US East 1 or maybe EU West 1, multiple different geographic regions, collections of data centers. And then we have availability zones, which are kind of like, they could be either a dedicated facility or a portion of a dedicated facility, like an AWS data center that has its own power, internet, basically an isolated zone, which is why it's called an availability zone, right? And we all know that like the point of availability zones is that AWS allows us to achieve high availability. And in case one AZ goes down, then we can have machines in another AZ. So our application will keep on working, even if like there's a fire in one building, for example, in US East 1. And so that's what availability zones are for. So one of the things with VPCs is that when you create them, you need to select the availability zones that you would like to create them within. And so typically what folks do is they span all the availability zones that are offered. Different regions, like US East 1, for example, has, I believe, 7 or so AZs, but other regions like in EU West 1 or in the AP regions may only have like 3 or 4, right? So the quantity of availability zones is quite different. And so within your VPC, you have this concept of subnets, okay? And there's two types of subnet. There's what's called the public subnet, and then there's a private subnet. And since we are creating a VPC here, let me actually just get my pen so I can point to thing or laser pointer. Since we're creating a VPC here that's spanning 3 different availability zones, like 1, 2, and 3 here, right? We would generally want to create subnets in each of the availability zones, both for the public and the private, right? You don't necessarily need like both of them. If you only want private subnets, you can just set up private. If you only want public, you can set up public, but the use case kind of depends. And so let's talk about public subnets first and kind of what they accomplish. Public subnets are kind of, as the name implies, you put resources in here that you want to be able to interact with the outside world directly, either making outbound calls to the public internet. It could be potentially other VPCs that you may want to peer into, or it could be you want to receive traffic from the outbound internet. Okay, so either outbound or inbound, that's where you would put your resources into a public subnet, right? So maybe for a typical application, maybe a web app or something, or a backend service, you would set up 3 different EC2 instances, one in each of the public subnets in each availability zone, okay? And this would ensure that if one AZ goes down, then the rest can take over the traffic. You'd probably set up like a load balancer here too that would span across these, but I'm kind of glossing over the details. And so the way that these public subnets talk to the outside world is through this component called an internet gateway. And the internet gateway is a piece that basically facilitates the communication both on the outbound side and on the inbound side, okay? So all of your internet traffic, or your traffic that's destined for the internet, will flow through the internet gateway, okay? And it also the other way around. Traffic that's incoming from the internet will flow through the internet gateway and into the respective instances, assuming they have all the permissions set up. So that's what public subnets are all about, like public connectivity, essentially. Now, private subnets are a different beast. These are more for pieces of infrastructure, resources, things that you want to keep hidden from the outside world, okay? So things that are most common to put here are like RDS databases, for example, because we don't necessarily want people from, you don't want someone coming from from like the internet to be able to hit your RDS instance. Like people can pull your entire database, right? Or maybe do something that'll compromise it. You want it like traffic to be flowing through into your EC2, and then your EC2 has connectivity to your RDS to query it to do whatever you want. And then maybe additionally, you may want to have like some special case to be able to access this RDS directly, which I'll show you how to do through something called a Bastion host, where you can still like use like pgadmin or like the MySQL dashboard to access your databases, even if they're in a private subnet. But essentially the key idea of private subnets is that put stuff in here that you don't want necessarily to be exposed to the outside world. Now you can have resources that you put in your private subnet, that are able to make outbound calls to the public internet, but are not allowed to receive incoming requests from the public internet. And we use a special piece of infrastructure that we'll get to a little bit later on in order to facilitate that interaction. Okay. So this is the key idea of VPCs. You have public subnets, you have private subnets, and then you also have like intra-network connectivity that you can set up, right? There's these different rules that you can specify to control the flow of the network traffic within your VPC. This could be traffic that's leaving your VPC and going out to the public internet. Could be traffic that's coming in. It could be intra-network traffic. You can lock down certain permissions or certain subnets so that only a particular other portion of your network can access it, for instance. There's a lot of power that you can do here. Although generally most networks that I've seen, at least in like my enterprise examples or enterprise experience, has been generally like you have your whole VPC open, so that the different open in the sense that the components within the VPC can talk to all other components. But of course, you can refine this if you wish. So this is kind of just in general how VPCs work. So let's move on now to some of the important concepts that you need to know about. The first one being address space and routing. And this is probably the most confusing part about working with VPCs. To be honest, when I was first learning it, I kind of just like brute forced my way figuring it out. And eventually like I got into a point where I needed to actually learn how this stuff works. And so I hope I can kind of shed some light on how CIDR blocks and IP address space works and help you out a little bit. But again, this is not going to be like a complete video on IP addressing. I'll defer to some of the other YouTube content for that, but let me just explain to you what you need to know. So let's keep this simple, right? Let's say we have an availability zone, one public, one private subnet. We have a VPC that's just for one availability zone, okay? And so one of the things to know about is that when you create a VPC, you need to specify what's called an IP address space or a CIDR block. And so I believe the default one that AWS recommends you when you create your account or create your VPC rather is this notation right here, or this CIDR block. So 10.0.0.0/16. So there's 4 numbers separated by 3 dots, and the range of these numbers is between 0 and 255, right? So you can have 0.0.0.10/16 and like basically any combination here. And then the /16 at the end here basically denotes how many degrees of freedom you have in the different spaces here. And this will make more sense in a second. But essentially when you create your VPC, the CIDR block represents all of the instances that you deploy within your VPC. What are the private IPs that they're going to get? So they need to be like kind of children of this notation here, which will make more sense in a moment. Okay, so when you create your VPC, you select this number here. You take the AWS suggestion, and you'll see this when we get into the hands-on part. But what does this mean a little bit more? Let's get into that detail. So what the /16 number at the end here, I want to say it denotes the flexibility over which digits are flexible in this notation here, right? So it works in 8-digit increments. So typically you would use 8, 16, 24, or 32 in this final number here. Those are generally the options, although you can go in between. But essentially this notation here, what it is telling us is that the last 2 numbers in this notation, so the 0 and 0, are flexible, okay? These 2 numbers can be anything we want within the ranges of 0 to 255, and the same thing for the other number, right? So we can have, if we were to use this notation, we can have IPs that would be, for example, 10.0.1.150. Right? That could be an IP that we create using this CIDR block notation. And so if you want to know the minimum and the maximum values using this notation, the minimum number would be 10.0.0.0. And that's like using the 0 here for the 3rd digit and the 0 here for the 4th. And then the maximum for this range would be the same thing, but .255.255, right? So using this notation, you'd have potentially 256 times 256 different IP address combinations. So around 65,000 or so different instances that you can provision in this network using this notation. So typically people will kind of increase or lower this number, which gives you more IP address space ranges if you're going to have a larger network. But for those of you that are going to have a relatively small one, this kind of IP address space with 16 at the end will be more than enough. Let's just do another brief example here using a different block here at the end. So we're using /24 instead of 16 here. And what this one is saying is that only the last number is flexible. And so just the 0 at the end can be between 0 and 255. And this means that we only have 256 different possible IPs that we can provision in this block if we were to go with this block, right? So the minimum, the lowest number would be this, and the maximum number would be this. So I hope this gives you kind of a general idea of how IP addressing works. It's not an accident that I'm using like the 10.0.0.0 notation here. These are conventions that are typically reserved IP spaces for private networks. And so that's kind of why AWS suggests it in their wizard and why I'm using them now, right? The other one that you commonly see is like the 192.168.0.1 notation. But anyways, back to the topic at hand here. So when you create your VPC, you specify this top level range. And then when you create your subnets, you need to specify a more narrow set of IP address spaces within this same notation that are going to be assigned to each of the respective subnets. And so with the public subnet and private subnet, I may give it this block notation. So 10.0.0.0/24, which means that I can have 256 different machines in this public subnet, and the last digit is flexible. So it can be between 0 and 255. Remember, private IP addresses need to be unique, right? And then for our private subnet, we pretty much did the same thing, but we just changed the third digit here from 0 to 1. And then similarly, the last digit, because we're using 24 block here, can be between 0 and 255. So we can have 256 different machines that are in this private subnet. And so this is the idea with public and private subnets, okay, in terms of IP address spacing. Let's talk about how like machines get IP addresses now when they're deployed into these subnets. Let's start with the public one. And so when you deploy a piece of infrastructure into your public subnet, there's a setting that you could specify, which is that it's called auto assign public IP addresses. And so what that'll do is that it'll give you a public IP address for this particular instance out of AWS's pool of public IP addresses. Now, since recently, there's actually a charge for every public IP address that you use, which kind of was something that sucks, and it's not too much per year, but it does cost money to have a public IPv4 address. They're trying to get people onto IPv6, but this is going to take forever. But for now, they charge you per month. Now, this would be the IP addresses that folks would use to talk to this particular instance, right? If you were outside and trying to SSH into it, or you're hosting a web server here on your EC2, people are trying to talk to you, you'd give people the public IP address, right? Now, you also get a private IP address that's associated with this instance, right? And so in this case, it will be 10.0.0.1, which is just an IP address that corresponds to this particular VPC, okay? Someone else can have their own VPC with that exact same ID if they want, but this doesn't have to be unique amongst the whole world, which is kind of what public IP addresses are for, but private ones are just unique for your particular VPC. And then similarly, we have on our private subnet, we have a private IP, and actually there's a slight typo here. This should be 10.0.1.128 because it should follow the same pattern here. I made a small typo there. Apologies for that. But essentially, instances that are in a private subnet will not have this auto-assign public IP address enabled, which means that they'll only be visible in your intra-network traffic within your VPC, that is. And so this is how kind of IP addresses get assigned based on the solder block notation that you set up for the subnet and for the VPC. Okay. Now, in terms of traffic routing, there's actually a component that exists within your VPC that's called the router. Now, you don't necessarily see the router, but it's controlling the traffic and how it flows within your network. And now there's this concept that the router uses in order to specify how traffic gets to flow. What are the rules for this particular VPC? Okay. And this concept is called a route table. And the route table is just a table that contains a set of rules. It's got a destination and a target. Okay. And the destination, let's actually take a look at this example here. What this first one does, it's basically saying 10.0.0.0/16. So the IP address space of our entire VPC, if that's the destination, then the target is local. This rule essentially means that our VPCs can talk to one another. Okay. They're allowed to speak to one another. Like this EC2 machine can interact with this EC2 machine. If you have any other subnets that are in this network, they can all talk amongst themselves and have visibility into the other machines. This is a very common rule that you'll see. You'll have the destination, which is just the IP of the VPC. Then you'll have local, which is kind of a keyword here that specifies that local access is allowed. Okay. And then this bottom one here is for internet access, more specifically for your public subnet, but it applies to both subnets here. And so what this is saying is, again, another kind of special keyword here, special notation. 0.0.0.0/0 is basically for the internet. It means public internet. Okay. So what this route table is saying is that anytime someone wants to talk to the public internet, I want you to route the traffic through the internet gateway. Okay. So it's not going to go directly to the public internet. It's going to point to the internet gateway. Having a route to the internet via an internet gateway is what makes a subnet public. Okay. So technically, both of these subnets have a route to the public internet. So in so many terms, you can consider both to be public. But the problem is that this private subnet does not have a public IP address, right? So even though it has technical connectivity to the outside world via the internet gateway, it doesn't have a public IP address. So it's not going to be able to make outbound requests and receive inbound requests. What typically folks do is that they create route tables that apply to specific subnets. So you can override these details here and apply a subset of rules to this subnet. And that's generally the way that people make this subnet like truly private. Or else if you don't do that, like all the subnets just inherit the main route table, which causes some problems for you if you're trying to set this up and ensure you have the right security best practices. But essentially the route table specifies the rules, the router kind of facilitates the traffic and as it flows throughout the network. That's the kind of TLDR about this whole thing. So a couple other small things to note here is that subnets are considered public. I kind of mentioned this only when they have a route pointing to an internet gateway. And the second point is that you can create custom route tables, which we talked about briefly too, and apply those to private subnets. So just two small points that I wanted to emphasize here. Okay, so now let's move on to a different example, one where you have a instance in your private subnet that wants to make external internet calls. It wants to talk to the public internet, right? Maybe it wants to download some data or do things like that. So we already learned that by default, when you have a piece of infrastructure in a private subnet, it's not able to receive inbound calls, right? It's also not able to make outbound calls unless you kind of set up some specific infrastructure. That's what's called a NAT gateway, okay? And so if this instance, this EC2 instance in the private subnet wanted to contact the outside world, what you would need to do is you would need to create the infrastructure, the NAT gateway instance in a public subnet, preferably in the same availability zone. And then what you would do after that is that you would create a route such that when your private subnet tries to talk to the public internet, it instead needs to be routed through the NAT gateway. Okay. And this is what the route table setup would look like in order to do this. So this is the same route table that we had before. It's, destination internet is going through the internet gateway. This is going to be the route table for the public subnet here. We would also set up a route table for the private subnet to control the NAT traffic flow. And so similarly, it's saying in the first entry here that it's able to talk to anything else in the network. And then in the second row, this is where it's key. We're saying that whenever it tries to talk to the public internet, instead of going directly to the internet gateway, I want it to target to the NAT instance ID. And the NAT instance ID, it's a unique identifier. You'll see this in the demo when we do this in the AWS account. It's just kind of like NAT ID dash some like hash of digits. But essentially, this will make it so that your instance is able to make outbound requests to the public internet, but not able to receive incoming requests from the public internet. So it keeps it truly private in that sense. And so to reiterate here, traffic that's destined for the internet is routed through the NAT gateway in the public subnet. Now, one other thing that I wanted to point out here is that NAT gateways are not free. They're like a dedicated instance. They're like horizontally scalable. They have redundancy built into them, but they do cost a certain amount of money. I can't remember the exact details. I think it's like 30 or 40 bucks a month, but you can kind of double check me on that. But these are not free, which is something that you're going to need to know about. Okay, so we learned about kind of the networking side of things and how to access the public internet and how traffic is being shaped through your route tables here. Now I want to talk about two different security concepts, two different firewall concepts. They're called security groups and NACLs, more commonly known as network access control lists. So let's talk about security groups first. And security groups and NACLs are just two firewalls, two security mechanisms where you can control what is allowed to talk to what within your network. We already saw how to kind of generally control this via the route table and just network rules, but security groups allow you to have just another more granular level of permission over who is allowed to talk to who, or what is allowed to talk to what. And so security groups are kind of like these containers that you can assign pieces of infrastructure to, right? So you can have security group A for these two instances, and you have security group B, which is for your RDS instance here. So one thing to remember is that security groups are applied at the instance level. So when you're creating an instance, you need to select a security group that it's going to belong to, and then the rules, like the firewall rules, will be applied to that instance as well. Okay. And then separately, security groups can be assigned to a wide variety of different AWS services. RDS and EC2 are one. There's also ECS. There's like caches in AWS Memcache. There's Elasticsearch service. Any basic piece of infrastructure where you want to control the inbound and the outbound, like who is allowed to talk to me and who am I allowed to talk to? That's essentially the purpose of security groups. You're going to need to use them. Okay. So this is actually probably one area that most people get tripped on is security groups. They're trying to figure out why can't I receive inbound internet access or inbound requests, or why can't I make outbound? They have a bunch of trouble here. And so let's say now a very common use case, you have like a machine in the outside world, right? Like a computer, and you want to have access for your EC2 machines to be able to receive traffic from this machine outside over here, right? Maybe it's like a user's browser or some kind of application that we're building, right? And so how would we set this up? And these EC2 machines also want to talk to this RDS instance, okay? And so what we would need to do is, if we want this setup where we have incoming requests from a machine to our public subnet, there's basically two perspectives you need to look at. There's inbound and outbound for every security group. Inbound rules and outbound rules. Inbound rules say who is allowed to interact with me. Outbound rules say who am I allowed to interact with. Okay, so it's kind of like two sides of a handshake. And so for the inbound rules for security group A, since we want to allow access from the public internet, we would need to create an inbound rule for, if you're using TCP in this case, you can specify the type. Also the protocol, it could be UDP, it could be SMTP. There's a whole bunch of different protocols that you can specify. The port range, you can specify any specific port if you want, or a range. And then the source. And in this case, the source is just the public internet. So this is the inbound rule, basically covers like this arrow here, or these two arrows, right? Now for the outbound side of things, what do we want to happen? We want these instances to be able to talk to the security group B, right? Security group A needs to be able to talk to security group B, both from the outbound perspective of security group A to B, and also the inbound perspective from B to A, right? B wants to receive traffic from A. So you'll see how this plays out. So let's look at the outbound traffic now for A, right? And so this should say that A is allowed to talk to B. And so what the outbound rule looks like is what we have here on the left. So we have the type, which is Postgres, protocol TCP. Typically Postgres runs on port 5432. And then we have the ID, right, of the security group, which is security group B here. So the outbound access is to this other security group. Okay, so now security group A has the right permissions. Now what does B need? B needs the inbound permissions, right? It needs to be able to say, I'm willing to receive inbound traffic from this. And so in order for that to happen, we would need to have an inbound rule for security group B, which says the same thing. I'm allowed to receive Postgres traffic on TCP port 5432 from the source is security group A. Okay, so this is the inbound rule for B. And then similarly And then finally for the outbound, there's no outbound rules here. Like the RDS database isn't making any calls outside to any other piece of infrastructure. So it doesn't need any outbound rules here, right? And so this is how you would use security groups to make this configuration happen, right? So more generally, security groups are used on a bunch of different infrastructure components. You could specify the protocol that you're going to allow access for. You're going to specify the port range, the source, which can be an IP, it could be a particular piece of infrastructure, things like that. So the thing to remember with security groups is that it kind of works under the model that like everything is denied unless you have specific access like configured correctly via the security groups, which is where most people get tripped up, right? Because you need to specify particular rules if you're trying to do something like this in order for this flow to work. And actually, this is one of the most common ones where you're trying to receive traffic from the public internet and then like talk to a database, okay? So this is security groups. Now, one thing to keep in mind with security groups, which is that requests are stateful, which means that if you have a security group like this inbound one that it's allowed to receive public internet traffic, it's also by default going to be able to respond with a response to the source of the call, right? Maybe it's someone's home machine on a browser, maybe it's something else, okay? So they're stateful, so they're bidirectional. Once a request goes one way, immediately it gets a channel back outwards in the opposite direction. This is not the case for NACLs, which is kind of what we're going to talk about now. They are stateless. So let's briefly touch on NACLs now, or NACLs. So similar to security groups, NACLs have inbound rules and outbound rules, but they add an additional level of granularity. They allow you to create rules, and let me actually just get my pen set up again. They allow you to create rules to deny specific IP spaces or CIDR blocks, or even specific IPs themselves, okay? So as you can see in this outbound rule here, we're saying that this destination is denied, right? So we're not able to make outbound calls to this IP address, but we don't have a matching rule for inbound. So this effectively means that we're able to receive inbound calls from the public internet, but we're not able to respond to them, which is different with security groups, right? With security groups, if you didn't have this, you'd be able to kind of receive an inbound call and then reply with a response. But NACLs are just another layer that you can add on top of this. And these follow a different rule where you can specify deny rules for large swaths of internet or public IP space if you'd like. They also operate on, let me actually have some pop-ups here. So yeah, they can deny certain IPs and protocols. They also are evaluated in sequence according to rule numbers here, where the lower numbers take priority. And so as it's kind of parsing your traffic and it's looking through the rule sets, it's going to see, like say we received an inbound call for this and we're trying to respond, it's going to see that this IP address, if we do receive that call from them, we have a deny rule here, so it'll deny that traffic. Whereas what we're saying here, like if it doesn't match this IP address, if it's someone else that's calling, it'll flow down to this rule, which is rule 100, and this is going to be allowed to respond because this is public internet, right? And we have an allow rule for that. And so this is the idea with NACLs, more appropriate for like blocking certain IP addresses or certain IP ranges for a piece of infrastructure or a collection of infrastructure. Okay, so that's it for firewalls and security groups. Let's talk about how you would go about accessing private resources now. So imagine that like you have some infrastructure that's in your AWS account and you have like your home network here, right? And your home network wants to talk to this EC2 instance, or maybe it's like an RDS instance or something like that. You want to be able to like interact with it, talk to it, maybe run PG admin for your RDS or do whatever you want, or maybe just SSH into the host. And so how would we get access from the public internet, like from our home machine, in order to do this, right? Now, the way that you do this, the most common way is using something called a Bastion host. What I typically call it, what a lot of people in the industry call it, is a jump box. And the name kind of implies what it does and what it's used for. And so what it is, a Bastion host is a piece of infrastructure or an instance that you set up in a public subnet that has inbound access from the public internet. It also has a security group that allows it to receive inbound access from the public internet. And so what this would allow you to do is once you set this up, and typically you would whitelist your IP address as well, just your IP address in the security group setup. You can say like, as the source, be my specific IP or a range of IPs. Then you would basically whitelist yourself so that you can connect to this instance. And then once you're in your EC2 instance here into your public subnet, you're able able to interact with the private subnet as well. So this will give you the ability to talk to instances that are in private subnets through this thing called the jump box or a Bastion host. And speaking of Bastions, there's a great solution called Twingate that can eliminate the need for Bastion hosts altogether. And they were kind enough to sponsor today's video. Twingate is a VPN alternative that makes it easy to connect to secure resources in your AWS account. Twingate uses a zero trust access system to ensure that your sensitive assets are protected at all times. It enforces least privilege access policies so that only users with the right sets of permissions can interact with your resources. It's also fast, can support hundreds of concurrent users, and is super easy to set up. In a previous video, I showed you how easy it was to use Twingate to securely access my private RDS database. Using Twingate, you can eliminate the need for a jump box and access your database as if it's on your local network. I got this all set up and working in less than 10 minutes time. Twingate is absolutely free for less than 5 users. You can give it a try today using my link in the description. Okay, so now I want to switch gears a bit to talk about how VPC endpoints work and why they're useful. Let's consider a case where we have our instance in our private subnet here, our EC2 instance, and let me just get my pen back again, and say this instance wants to talk to Amazon S3, okay? Since this instance is in a private subnet, it's not going to necessarily have direct internet access. So say we set up our NAC gateway instance like we saw in the previous slides, that we need to have a route table entry that says like, okay, anything that's destined for the internet goes through the NAC gateway in the public subnet. Then your traffic will go out via the internet gateway. And then now your traffic is outside of AWS. And then it's coming back into US via like an external call to the public S3 endpoint. Okay. And so this is how you'd have to get access to S3 if you were trying to access it via a private subnet. Not ideal. You'd have to pay the overhead of the NAC gateway. There's a whole bunch of like other implications as well, security implications here. Your traffic is leaving the AWS cloud, which isn't ideal. There's also cost concerns too. There's egress costs. And so that's kind of what we're trying to avoid, right? And this is what VPC endpoints allow you to avoid. And so how you would set this up, or how this would look in contrast, is that you would set up what's called a S3 endpoint via the VPC endpoints feature. And what this allows you to do is set up like a private endpoint that's going to point directly within the AWS network to S3. And then you would set up a route table entry that would say, okay, now anytime anyone's trying to call S3 from a public or a private subnet, just go to the S3 endpoint as opposed to having to go out through the public internet and then back in. So that's just like an easy way that you can use to set up access to AWS services that need it in private subnets, okay, instead of having to use a NAC gateway. For S3 and DynamoDB, by the way, this feature is free, but for other AWS services, there's a nominal cost. But again, this beats like having to set up a NAC gateway. So as we learned, using this feature allows you to avoid using NAC gateways and the associated costs with them. Similarly, endpoints will require security group configuration. So if your EC2 instance wants to talk to the S3 endpoint, then you're going to need to have an outbound rule for your EC2 instance to talk to this endpoint, and then similarly an inbound rule for the S3 endpoint to be able to receive traffic from your EC2. And you'd need to do the same for both security groups in both subnets if you had it configured that way. So that's it for VPC endpoints. Now I want to move on to just some other useful features that you need to know about when you're working with VPCs. The first one is VPC peering. This feature allows you to connect different VPCs together. So say you had like one VPC in your account and a second VPC in your account, you want the traffic to be able to flow between them. You can use VPC peering to do this. It's pretty straightforward and easy to set up. You can also do this for VPCs that are in other AWS accounts, provided that the IP address space does not overlap. This is something I'll walk you through on how to ensure it, or do your best to ensure it doesn't overlap in the hands-on part of the video. Then there's also AWS private link that allows you to also connect using a different mechanism to other VPCs. You can create associated endpoints as opposed to just opening up your whole VPC using VPC peering. And then another mechanism to gain access to your VPC instead of using a Bastion host or a jump box is using something called client VPN. And this is similar to like, VPN that you'd have at your business or your work. You'd use a client to kind of sign in, you have a password, and then once you're into the network, it's as if you're on the private network while you're on your home machine. So that's AWS client VPN, which can be useful in certain companies as well. Okay, so now let's move on on now to the hands-on part of the video. And so we're going to talk about a couple sections here. The first one, I'm going to show you how to create a VPC with public and private subnets. Going to show you really quick. It's straightforward, easy to do with the AWS wizard provided. And then I'm going to show you how to deploy an EC2 or RDS instance into these subnets to see how they get assigned IP addresses, both public and private. I'll show you how to configure security group permissions so that these things can talk to each other. And then also I'll show you how to set up a VPC endpoint. Possibly we'll get to NAT gateway as well, but we'll see how long things take. But I will see you in the AWS console where we'll tackle some of these items. All right, folks. So here we are in the AWS console. So let's get started by first navigating over to the VPC section of the AWS console. We're going to go to the top here, just type in VPC and click on the first entry here. So the default page here gives you a preview of all the resources that you have by region. So if you were to change your region, I'm in US East 1, for example, to something else like US West 2, you'd be able to see it quickly at a glance, all the different resources that you have here. So you can see I only have one VPC in this account, which is the default VPC. I have a couple subnets that got created that are associated with it, and then a couple route tables as well. Pretty much everything that we see in this account is all default. I haven't really messed with anything. So the first thing that you'll notice is that over on the left-hand side here, there's a bunch of different stuff that you can select from, like network firewalls, VPNs, verified access, transit gateways. And this is really why a lot of people get very confused with using VPCs, just the sheer amount of options that you have at your disposal. But the truth of the matter is that a lot of these different options here are useful in very specific circumstances. And there's a core set of features that you need to know about in order to be proficient with VPCs, which is kind of what we already talked about in the PowerPoint presentation. But let's start out by just taking a look at the default AWS VPC that we have as part of our account. And so I clicked on your VPCs here. And so this is the default AWS VPC, as you can see. If you click on it, you'll be able to see a bunch of the different options that are related to it. So you can see the main route table, it gives you links here, it gives you the main network ACL or access control list, which is what we were talking about in the previous presentation section. And then you can also click on this resource maps section, which gives you kind of a visual breakdown of what this VPC contains and all of the subnets. And so you can see here under the subnet section with an A with a green means that it's a public subnet. And then the A with the blue means it's a private subnet. And you can see this one has a private subnet in US East 1A. And this looks like to be because I was just messing around with something like a private demo route table. So this normally isn't here as part of just the default setup, but as part of this VPC that I have in front of you, obviously it's here. So you can see all the different subnets that it has as part of this VPC, one in each availability zone in the region. And then you have the route table. This is the main route table that's associated with the account, or with the VPC rather. And you can see the neat part about using the resource map feature is that it shows you the connectivity, right? So this is just a nice handy way to see how everything is connected with this VPC, okay? And there's a very similar way when we create our VPC to, as we're creating it, to specify what we want in terms of the public and the private, and it'll generate a nice little preview similar to what we're seeing down below here. So we can validate everything before we kind of shoot off and create the VPC. You can also poke through some of the details here. So you can see like this is the CIDR block for this VPC, which is, I believe, default for AWS accounts or new AWS accounts. You can also see the flow logs. Flow logs are essentially how you understand the traffic that's flowing through your VPC. They're a little bit verbose, and you need to kind of read the documentation to understand how to parse them. You'd have to create them. They don't exist by default, so you need to create a flow log, and that'll emit metrics into CloudWatch for you. So that is it for the default VPC. Let's get started now with the task at hand, which is to create our first custom VPC, right? We're not going to be using default here. And so what we're going to do is we're going to go to the top right section here and click on Create VPC. And if you see here, there's this section. You can either create just the VPC, which is typically how this wizard used to work in the past. But more recently, they added this feature called VPC and more. And this will allow you to create not only the VPC, but also the public and private subnets, the associated route tables, the internet gateway, everything that you need basically to get started with your VPC is all in one shot. And the nice thing about using VPC and more is that when you come to the point in time where you want to clean up and get rid of your VPC, once you delete it, it'll also delete everything else that's associated with this particular VPC that was created as part of the wizard. So that's a nice little extra bonus that you get here. So we are going to select select VPC and more here, and you can see this was kind of that wizard thing that, or the preview that I was talking about before. So you can see by default, it's going to create a VPC for us. That's going to do this in 2 availability zones, 1A and 1B. We're going to have a public subnet in each. So a public subnet for this is this one, and the public subnet is that one. Private subnet in each as well. So this one and this one. And you can see when we hover over the private subnets, which is what I'm doing now, there's a custom route table for each of the private subnets. This is for 1B and this is for 1A. And then you can also see that we have a VPC endpoint for S3 and then an internet gateway for the public subnet. But we're not going to use just this default configuration. We're going to change this a little bit to work with what we want. So let's do that now. So the one thing you can do with this wizard, which is kind of nice, is that you can untick this option. And as you can see, it allows you to customize the names for each of the VPC itself, the subnets, the route tables, et cetera, et cetera. This is a really convenient thing to do. It's actually something that is kind of just a best practice in general, which is to use very descriptive names for both your VPCs, your subnets, your route tables, security groups, NACLs, all those things have descriptive names because it's very easy to lose track of what is doing what and then having to click through multiple different screens to understand what is going on. So we're going to give this a custom name. So you can just click into the VPC here and we're going to say my first VPC. Okay. And we are going to, before we fill out the names here, we're going to make some changes to the CIDR block here. So as you can see, like this is something that we talked about in the PowerPoint as well. You can see the custom CIDR block. You can see the CIDR block that is being suggested for us here is 10. Oops, giving us a little thing here. 10.0.0.0/16. And as we learned previously, everything in these two places are degrees of freedom, right? So we can have any number between 0 and 255 for the IP address space that is when the instances get launched. And we can also have any number between 0 and 255 for the last digit here. Now, one thing that you should know of is that when you use the feature VPC peering, which allows you to basically connect 2 different VPCs together, one problem that people usually run into is that if you have your VPC set up with the same IPv4 CIDR block as a different VPC, you're not going to be able to peer to each other. Okay, so what that means is that if you set this up as default 10.0.0.0/16 in your VPC or this VPC, and your friend or someone else sets up the exact same VPC using this exact same CIDR block, then you're both going to have some problems. You're not going to be able to set up VPC peering down the line. For this reason, I suggest to modify the default CIDR block here. And a simple way to do this is just to modify the second digit here, right? So instead of saying 10.0, you can pick anything between 0 and 255. So let's say like 10.200, for example, okay? And so now if someone uses the default, which is normally 10.0.0.0, you're going to be able to peer into them no problem. So just a little bit of a pro tip for you to apply right out of the get-go so you don't run into a problem for your future self. Okay, so we're going to leave the rest as default here. We're going to use the 16 CIDR block here. So the last 2 are the degrees of freedom. We're going to leave 200 as well. It's asking us for an IPv4 CIDR block, which we are not going to use. Default tenancy is good for us. It's also asking us for availability zones here. So how many availability zones do you want to create here? So we're just going to set this to 1. So you can click on Customize AZs if you want to select a specific availability zone here. For the first available, we're just going to leave it as default here. You don't need to mess with these options. And then you can specify the number of public and private subnets. If you need to add more, you can always do this after the fact, but this is just a kind of out-of-the-box suggestion here. Now, the neat thing about using this wizard thing as well is that you can customize the subnet CIDR blocks, okay? And so this is going to be kind of similar to what we had in our PowerPoint demonstration. So I'm going to change this a little bit, actually. I'm going to say instead of 20, which is something you can do, you can have numbers between 16 and 24 and between 24 and 32, but I'm going to change this out. You can see when I change this, the number right now is 4,096 different IPs that are available to us. This is going to drop down to 256 whenever I change this to 24 because it's lessening or lowering the degrees of freedom that we have in this final digit here, which is kind of why the IP space is being restricted. This is fine for our network because, we're never going to run into this many machines. But if you have a very large network that you're trying to provision, then you may want to do this. Now you're also going to see here that the third digit, it's 0 for the public subnet, and it's being auto-suggested to use 128 for the second subnet, for the private subnet. And the reason that they do this is because if you want to add like multiple other subnets later, you typically want to like add them in increasing numbers. So it's leaving something like in between. So like later on, you may be able to create one that's like, 64, and then later like 32. And then it's basically just giving you enough space so that you can add more digits later if you need to. And if you were to change this to 2, for example, you can see how this kind of changes as well. So it's the 128 for the first subnet, private subnet, and then 144. And remember, this can go all the way up to 255 if we want. But let's just leave that with default here. So we're just going to have 10.200.00/24, going to give us 256. And then also 10.200.128.0/24, also going to give us 256, which is fine for us. Now, a nice part about using this feature as well is that it does the NAC gateway setup for you if you wish. So since we only have one private subnet rather, we're only going to need one NAC gateway in our public subnet. So I'm just going to click on one in AZ here. And if we scroll up to see what's going on, we should start to see this taking form. So if we scroll to the right a little bit, you'll see that for our public subnet, if we highlight over it, it's pointing, it looks like the UI is getting a little bit messed up here, but you can kind of make out what's happening. The public subnet has a route, or it's associated with the main VPC route table, which has a route to the internet gateway, which is good. That's what we want our public subnet to do. And then you can see our private subnet has a custom route table. And this route table contains entries that point its outbound internet access to the NAC gateway. And it's also going to have an entry for a VPC endpoint, which is something that we were just about to select. But let's just take a look at that now. It's right here. So VPC endpoints, you can set this up to use S3 just out of the box. It'll do this for you, or you can add this later, which is something I'll also show you how to do, but it's a pretty straightforward process. Now that's all you really need to do in order to create your first VPC. Now, one thing I want to do before we move on is just go up and modify the names. So we're going to call this one public-1A, and we're going to call this private-1A. For the private subnet. And we're going to call this the main route table for the VPC. And then this one is going to be called private-1A-route table. Excuse me, I mistyped here. Sometimes my brain moves faster than my hands. And then for internet gateway, it doesn't really matter. I'm just going to put in IGW, and then NAC gateway, I'm just going to say NAT. And then for VPC endpoint for S3, I'm just going to say VPCE-S3. So these are just going to be some shorthand names that I use so that I can understand what is going on here. So this is looking good. Got the main route table, we got our subnets, we got our private route table, and all of our endpoints. I think we are ready to move on to the next step here. So let's scroll all the way down to the bottom. We're going to click on Create VPC now. And as you can see, it's doing a bunch of things. It's creating a bunch of stuff for us. And this is the nice thing about using the wizard here is that it's going to kind of create all the infrastructure for you. It's going to populate the route tables. It's going to set all the good stuff up so that you don't need to do all of this manually. However, if you are interested, I do suggest, like, if at one point you want to create all this stuff manually to just essentially go through the motions yourself, you can certainly do that. It's just going to take you a little bit more time, but you'll probably gain a lot more understanding that way since you're literally creating every single piece of infrastructure. But for those of you that are trying to get started quickly and trying to understand how everything works, then this is definitely the way to go. So you can see now it is taking a little bit of time, and that's because we provisioned a NAT gateway, and a NAT gateway is essentially like an instance. It's like an EC2 instance, although they don't actually like call it an EC2 instance, but they are setting that up for you right now. So AWS is provisioning that for us. And then it's going to create the route table for us and then create the routes for the NAT gateway, so on and so forth. So if this takes too long, I'm just going to fast forward the video and then come back when it's all done. So I'll see you in a minute. Okay, so everything completed here. It just took another minute or so. So if we go to view VPC now, we can see all the details for this VPC, similar to what we saw in our default, right? So you can see here, our resource map is exactly what we defined earlier. So we have, actually, is this the right VPC? Yeah, this is the one here. Default VPC, no, okay. Yeah, so this is the right one. So we have our main route table here. We have our private route table. What is this actually? I didn't create this. route table. This is something else. I'm not sure how this got created or why, but I'm sure there's an explanation for it. Maybe I'll poke around a little bit later to see what this is all about, but kind of interesting. That doesn't seem to be associated with anything, so that's bizarre. Anyways, we'll come back to that a little bit later if we want. Okay, so we have our VPC set up. We're good to go. The next thing I want to do is I want to create a couple security groups. I want to create 2 specifically, and I want them to be able to communicate with one another. So let me show you how to do that really quick. So we're going to scroll down here. We're going to go under Security tab to where it says Security Groups. And you can see I already have like a ton of security groups that are associated with other VPCs, but we are going to, and you can see like the security groups are scoped to a particular VPC. So if you create a security group for one VPC, you won't be able to reuse it for another. You'll have to create another copy of it. But anyways, what we are going to do is, let me just find the slide here over on the left here, and I'll bring it over so you can see what I'm going for here. Basically, we had this setup here, right? We had like a security group A and then security group B. We wanted these 2 things to talk to each other. We had an instance in this case, but I'm just going to like basically bring this EC2 instance. Oops, that doesn't work. I'm going to bring that EC2 instance over here. Let's get rid of that. So we're going to have basically 2 different security groups, one with an EC2 instance in each, and then we're going to basically set up the connectivity so that these things can talk to each other and also enable inbound internet access from an outside machine for security group A. Okay, so that's basically what we're going to be doing here. So I may bring this back up once in a while so we can see it, but that's the goal. Okay, so let's go to create security group now. And so I'm going to scroll all the way to the top. We're going to give this a name. We're going to call this security group -A. So this is for our first EC2 instance. So inbound rules. So what do we need to do here? Well, first we need to add an inbound rule to receive all traffic from the public internet. Okay. This is going to allow us to receive any incoming requests coming from the public internet. You can also restrict this to like just TCP or UDP or some other kind of protocol if you want, or if you just want to enable SSHing. This is actually what you would do for your Bastion host or your jump box. You would enable just SSH on inbound on your security group for your Bastion host. But you know, we're just doing this as if it's some kind of web application here. So we're going to click on all traffic here, and then source, you can say anywhere, like any IPv4 address, which is fine, or you can whitelist it and say only coming from my IP address if you want. And this will autofill whatever your IP address is. So you can say anywhere IPv4, and this is going to give you like autofill for IPv4. And if you want to enable it for IPv6, then you would need to add like a second rule and then just select the same thing, but for IPv6. So this is looking good. It's allowed to have inbound internet access from the public internet. Now, outbound rules, we don't need an outbound all traffic internet access, right? Because as we learned, security groups are stateful, which means that if you make an incoming request, then you'll be able to respond. So we actually don't need this outbound rule right now. But what we will need is we'll actually need to come back to this security group a little bit later, because remember, we need to set up both sides of this relationship, right? We need to set the outbound rule for this to be able to talk to security group B. But we haven't created security group B yet. So we're kind of in a chicken and an egg scenario. So first we need to create this security group A instance. And I've already enabled this kind of rule here so that we have inbound internet access enabled. But then after we create B, we need to come back and modify A so that it gives it the outbound access. And so we're going to leave this as default, you know, without anything else besides what we already did for public internet access. Going to click on create security group now. And okay, I don't need description. That's nice. Description. Cool. Let's try that again. Create security group. All right. Doing the things. Awesome. So this is created now. Let's create another one now for security group B. And same thing. So we're going to go up here, secure. Oh, did I? You know what? I think I did this in the wrong VPC. Shoot. Okay, so I made a little bit of a mistake here. I made security group A in the incorrect VPC. So let's actually go and fix this. It's only going to take a second. So you can actually, I'll show you the process of deleting actually. So you can see, yeah, this was in the default VPC. So that's a little bit of a mistake on my part. That's fine. So let's just get rid of this, delete security groups. We're going to delete that. And this will just take a second. Let's just fix this. We're going to name it again, security-group-A, and put whatever in here. Remember, you need to select the correct VPC this time. And then for inbound rules, same thing. So all traffic, and we're coming from anywhere IPv4, and then we want to delete outbound, and then we're good to go. Okay, so this should be good now. So we are associated with the correct VPC ID. Okay, so let's go ahead now and create that second one for security group B. So we're going to go to create security group. And this one, we need to create an inbound rule to allow all traffic access from security group A. So let's do that now. We're going to say add a rule. We're going to say all traffic. And source, this time, as you can see, when you click on into this block here, you can actually select the security group. I should be able to see it here. So security group A. I wish it was alphabetical, but it doesn't look like it. But oh, you know what? I didn't select the right VPC. Almost made the same mistake twice. And that's kind of why all those other security groups were showing up. But anyways, we have security group A here. So that's exactly what we want, right? We want inbound connection or inbound traffic from security group A. So that is good to go here. And remember, we don't need any outbound access for security group B, right? Like we don't need B to be able to like call anything else. So we can actually delete the outbound. So we're going to go here and security group -B and whatever here for description. I'm going to go on and click on create security group. And now we just need to go and fix security group. Man, I can't type. I think I misspelled that too. Security group -A. Okay. And then we need to go into this, and then we need to, for outbound rules now, we need to edit outbound rules. We're going to add a rule and say all traffic. And then the destination is going to be, yeah, man, I misspelled that. I'm such a dummy. It's okay. We're going to click on that security group B for the destination. We're going to go on save rules now. Okay, so we now have this setup that we just basically talked about here. We have the incoming from the public internet for security group A. We have outbound for security group A to talk to security group B. And we have inbound for security group B to be able to receive traffic from security group A. So we're basically good to go on the security group side of things for just the EC2 instances in question here. Now what we can do is we can just deploy some instances into our respective subnets, right? So let's go ahead and do that now. I'm actually going to open a second tab here. I'm going to duplicate. Let's go to EC2 and that one. And then we're going to go to instances and we're going to launch an instance, or if you click on up here to launch instances, and then you can call this whatever you want, instance, or like public instance, right? Oh, man, my typing is really bad today. And then you have like the different options for types that you can select from using the free tier eligible AMI, and we want a T2 micro, that's fine. Key pair login if you want to be able to SSH into this. I already have one. I believe I created, yeah, like a test one, that's fine. So that you're able to SSH into this later. And also it's going to ask us now some of the configuration settings, right? So you can see it's auto selecting the default AWS VPC, and it's like asking us to create a new security group. We don't need to do this. So we can actually modify this. So we're going to instead select our custom or our my first VPC, and we're going to select the public subnet, which is public 1A, and then auto assign public IP. Yes, we do want that. We want a public IP address for it. Keep in mind, there is a charge for this since it's IPv4, which we talked about in the previous, but that's fine. So now we're going to go to select existing security group because we already went ahead and created one. So we don't need to recreate one from scratch, and we have all the rules set up correctly. So we're going to click here, and this is for our public subnet. So that's going to be for A. So we're going to select that, and we're pretty much good to go here. We don't need to do any other advanced like network configuration setup. We don't need to set up any secondary IPs, storage. We don't care about advanced details. Is there anything here? No, there's nothing here that we care about. This is just like termination behavior. We can pretty much just launch this instance now and we're good to go. And so we are creating this instance and yada, yada, yada. So it's going. And now if we go back into instances, we should eventually be able to see somewhere here. Okay, this is the public IP address. That's great. And the launch time, we should be able to see the VPC that it's deployed into. Maybe I got to select it, VPC, Control F. There it is, yeah. So it's associated with my first VPC, which is exactly what we wanted. Okay, perfect. Let's just create a second instance really quick, basically doing the exact same steps. So launch instances, and I forget, what did I name this thing? Public instance. I'll name this one private instance, private instance. Did I have a dash? I think I did. Private instance. Basically the same settings, T2 micro, everything's fine there. Select our key pair. We're going to edit the network settings, change the VPC name to be the one that we just created. Auto assign public IP. Make sure you have this as disabled because this is going to kind of violate the idea of it being a private subnet. We don't want it to have a public IP address that exposes it to the public internet. And then we also want to select an existing security group like we already did. And now we have security group B instead of security group B. So we're going to click on that one. And again, everything is good here. So we're going to go ahead and click on launch instance. And we're pretty much good to go at this point. We created these 2 instances, associated them with the right security groups. And so this should all be gravy. And so what we can do really quick, just to verify all this is working correctly, if we refresh just to make sure this is all up to date, we can see now, we scroll right, we see the public IP v4 address for our public instance is available to us, right? So this is the address here. So I'm just going to grab this, and this is the DNS name, by the way, if you wanted to use the if you want to use the DNS as opposed to the IP address itself. So I'm just going to drag over my PowerShell over here. And so I copy that to clipboard. So this should have inbound internet access, right? So I should be able to ping it just using the ping command, and I'm just going to paste in that IP and let's see. Yep, so we're able to ping it and we're getting some response data. So this is working correctly, right? We have internet access to our public instance. And if you wanted to verify that our private instance has connectivity to our public instance, basically what you'd have to do is you'd have to get into your private instance, you'd have to SSH into it, and then once you're in, you can ping the private IP, which should be somewhere here. Okay, it's not actually listed as one of the columns. I believe we can probably change this, right? There it is, private IP. Here we go. So we can add these, confirm, and you can see here, yeah, so here are the private IP addresses. And as you can see, when we set up the subnets, right, we set up the CIDR blocks. For the public subnet, we said 10.200.0.0/24, right? So the number that it chose, it can be between 0 and 255. So it chose 181. And for our private subnet, we did the same thing, but instead of 10.200.0.0, we did 10.200.128.0. And then we also did a CIDR block of 24. So that means that this can be anywhere between 0 and 255. So you can see it picked 238, obviously. So we can see here that our CIDR block notation is working as expected here. So everything is going well and good here, right? So we have our instances, we have our public and private subnet now. We also have our security group set up, and we have connectivity that's been established and set up correctly as well. Let's set up connectivity for our, let's say our private instance wants to talk to some other AWS service, right? So we want to set up a VPC endpoint to do that, okay? So in order to do that, we're going to look for VPC endpoints. I'm just going to it's not going to be here in the EC2 section. It's going to be in the VPC section of the console. So we want to go somewhere here. It'll say something about endpoints. Let's just do endpoints. There it is. Okay. So we're going to click on endpoints here. And so this is the section that we're going to be able to create our VPC endpoints. Now we can go ahead and create endpoints right now if we want, but one of the things that we need to do is we also need to create a security group that gets associated with the VPC endpoint. So if we go back to our diagram here, this was kind of the security group thing that we were talking about, or VPC endpoint slide that we were talking about, if you recall. And so we were saying that, you know, when you create a VPC endpoint, it's going to allow you to keep your communication within the AWS cloud. But also associated with this VPC endpoint is a security group. And like we learned, you need inbound rules on this security group from whatever wants to talk to it. Say that's this EC2 instance in the private subnet, right? So you need inbound on the security group for the endpoint. You also need outbound on the security group for the instance that wants to talk to the VPC endpoint. So you need a security group to be assigned to the specific VPC endpoint that you want to communicate with, right? And the unfortunate part is that as part of this wizard, you're not able to create them inline. You actually need to go to the security group section of the console and create it yourself. So let's just do that really quick to make our lives a little bit easier. So we're going to go back to security groups, create a security group. We're going to call this one VPC-SG. And sure, not the default. We want it to be our custom. And what do we want this to allow? We want inbound access. I'm just going to delete the outbound. We want inbound access from our private subnet or security group B effectively, right? For all traffic. So we're going to say all traffic and then group B. is the source, and that should be good, right? So this covers one half of the equation. So we're going to create that security group. And why not? Since we're already here, let's go modify group B really quick to give it outbound access. So gru-b, and we're going to go into this and that guy. And now we need to give it an outbound rule. So edit outbound, going to add a rule. We're going to say all traffic again, and this time it's going to be the VPCE that we just created, right? So this should set us up for the VPC endpoint that we can now go ahead and create. So let's go to endpoints now. And whoa, that's weird. Yeah, so that was strange. So we have VPCE for S3. This is what we already created as part of the setup in the wizard itself. But let's create something different, right? Like let's create something for, I don't know, what service do we want to do? Let's go to create and figure it out. So like VPC-E. Let's pick something different, like the SNS service, for example, or simple notification service. So I just typed in SNS. I left this as AWS services. By the way, you can also use this feature to talk to other VPCs. So you can create an endpoint to like a load balancer in someone else's VPC. So you have a dedicated endpoint for it. So you can learn about how to do that using other endpoint services, but kind of beyond the scope of this. So we're going to just select SNS here, and then it gives you the service name. So we're going to select on this. We also need to select which VPC to create your endpoint in. We want to select our My First VPC, and then anything, yeah, we don't care about that. You also need to specify which availability zone that you want to create it in. So for us, it's going to be 1A because that's where our subnet is. So we're going to click on that. And for subnet ID, we want this to be our private subnet, right? Because that's what's going to be communicating with SNS in this case. You can also tick this box here if you want to specify the IP address that this endpoint gets, but it's not necessary. It'll auto do this for you if you leave it as default, or leave it as blank rather. Anyways, we should be good here. Now we need to say, okay, this was the point that I was talking about earlier. We need to select the security group that this endpoint is going to be associated with. So that's going to be this one, the one we just created. So VPCE-security group. And so we selected that. That is now good. We should be able to go down now and just click on create endpoint. And we should be good to go here, right? So we have this security group, or have this VPC endpoint getting created now, and we have the security group set up correctly. So now our EC2 instance that is in the private subnet with a private IP address should now be able to talk to, or once that endpoint gets set up and DNS gets populated, it should be able to talk to SNS without having to go through the public internet. So that's a big win for us here. So yeah, that is basically the extent of this video. I hope you found this helpful, or able to understand a little bit more about VPCs and you're not completely intimidated by them. If you have any questions or comments, be sure to leave them in the comment section below. And thanks so much for watching. I'll see you in the next video.